So as I told you that F is proportional to Q1, Q2 and F is inversely proportional to 1 upon R square. These are the two important relations which you need to understand to explain the ionization enthalpy. Now see, the moment you are moving from left to right, what is going to happen? Basically, the number of electron is going to be increased, as well as the number of proton is going to be increased in the nucleus. But the distance is not going to be changed, right? So in that case, I can say if I will take the formula F is proportional to Q1, Q2 and F is inversely proportional to 1 upon R square. So R is not going to be changed, so it is not going to contribute anything with respect to force of attractions. But suppose Q1 belongs to the number of proton and Q2 belongs to number of electron, then across the period both are going to be increased. Electrons are going to be increased as well as proton is also going to be increased. So I must say that F is going to be increased, force of attraction is going to be increased. So the moment you have start adding the electron in the same cell, basically the force of attraction has been increased and they pull towards the nucleus, right? Now, because of higher force of attraction, it's difficult to remove the electron from the outer valence shell. And in this process, the energy which has been required will be quite higher. And that's why across the period, the ionization potential is going to be increased. Clear है? अब group की बात करेंगे, so it's a totally reverse phenomenon. Right, means additional with the atomic distance, one more term has come into the picture, that is shielding effect. But if you will compare, since I'm moving from left to right, there will be no change in the atomic distance, only the variation can be noticed in the charge, and the charge is going to be defined with respect to nucleus as well as valence shell, and both are going to be increased. That's why force of attraction increase, and across the period we need a good amount of energy to remove the electron, and that's why ionization enthalpy across the period is increased. However, I'm moving from top to bottom, since the distance is going to be increased with respect to the nucleus. Of course, common सी बात है, क्योंकि number of cell is more now. So F is having inversely relations with the with distance. अभी distance जब बहुत ज्यादा होगी तो inversely का मतलब क्या हुआ, force of attraction कम होगा, and just imagine the relation is inversely proportional to R square, right? यानी थोड़ा भी अगर R change होगा तो double दिखेगा और उसके respect में F is going to be decrease. So on moving from top to bottom in group, basically R get increased drastically, and that's why force of attractions are going to be limited. Okay, now these are the reasons which I need to be shared for you for these 4 questions. Now come back to the point, why across the period we see some irregularities, especially if you will see in this graph. Let us show it. For example, if you will see beryllium, boron, nitrogen as well as oxygen, right? Now see, actually in a normal prospect, what should be happen? The boron should have higher ionization potential with respect to beryllium, and similarly oxygen also should also have higher ionization enthalpy with respect to nitrogen. But if you will see the graph pattern, you will come to know that beryllium is having more with respect to boron, and similarly nitrogen is having more with respect to oxygen. The rest of the pattern is as expected. Now see, if I will try to plot a graph between ionization enthalpy and atomic number by removing this beryllium and nitrogen, you see what the pattern will come. This pattern will be this way, right? I'm not considering beryllium and nitrogen. So the statement which we have given across the period is the ionization enthalpy is going to be increased. It's truly a workout here, right? But suppose if you will consider the beryllium, now the pattern will be, you see, it will be like this way, whatever. So actually to hum can be noticed, right, across the period. Now the thing is why. See why. चलिए बात करते हैं बेरिलियम की और बात करते हैं बोरान की, हम यही तो कह रहे हैं. अच्छा, beryllium having the electronic configuration 4, however boron is having a electronic configuration 5. बराबर. अब चले इसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन लिख देते हैं. सो बेरिलियम इलेक्ट्रॉनिक कॉन्फ़िगरेशन विल बी 1s2 and 2s2. सही है. नाउ सपोज बोरान के बारे में बात करें तो क्या होगा. इट विल बी 1s2 2s2 and 2p1. ठीक. अच्छा, suppose after the ionization what will be the electronic configuration of beryllium. just imagine, एक इलेक्ट्रॉन निकाल देते हैं तो क्या आएगा. आएगा 1s2 and 2s1. यही तो होगा आफ्टर द आयनाइजेशन में बोल रहा हूं. ठीक है. अच्छा, जस्ट see after the ionization in case of boron what will be the electronic configuration. Now it will be 1s2 2s2. यही होगा. So beryllium will have the electronic configuration after the ionization potential is 1s2 2s1. However, in case of boron, the electronic configuration will be 1s2 2s2. अब देखिए, in case of s orbital, the maximum number of electron या fulfilled configuration used to have 2 electrons in a cell. Now, how many are there in beryllium? Already 2. But after the ionization process, s orbital will have 1 electron. So in short, I can say earlier beryllium was stable in nature, but after the ionization process it has to opt unstable configurations. I have already told you by default nature used to obtain the stable configurations, right? And beryllium is having stable, but after the process it is having unstable. Just think whether the beryllium will allow to get unstable. No, it will resist, and the moment resistance will come into the picture means you need to put extra energy to compensate this resistance, and that's why beryllium is having higher ionization energy with respect to boron. Because boron is having the valence electron in a p orbital. By shedding this one electron, it is going to obtain the configuration similar like beryllium, and that is stable configurations. So earlier boron is bit unstable, but after shedding the one electron, it has obtained the electronic configuration of stable nature. So of course it will try to release very easily the electron, and that's why the lesser energy will be required in case of boron. But the moment it comes for the beryllium, it will try not to release the electron, and just you want to make sure that it has to be, and in that case you need to put extra energy. That's why beryllium is having more ionization potential with respect to boron, right? Clear है? आगे बढ़ूं? आगे बढ़ूं? अच्छा, अब देखिए दूसरी irregularity. Now if you will see the second irregularity, notice where actually on comparing the ionization enthalpy of nitrogen and oxygen. देखिए ध्यान से. Actually in a normal way होना क्या चाहिए? The oxygen should have more ionization energy with respect to nitrogen, but हो क्या रहा है? Nitrogen is having more with respect to oxygen. Always remember, in any orbital, half filled or full filled configuration or the stable one. Half filled मतलब अभी देखा जाए तो p के केस में मैक्सिमम इलेक्ट्रॉन कितने हो सकते हैं? 6, और हाफ फील्ड में कितने होंगे? 3. So if any p orbital have 3 electrons, it means it is half filled. It means it is stable with respect to the any other configurations. ठीक है. अब P3 से ज्यादा स्टेबल क्या होगा? P6. P6 में क्या है? Maximum electron in the p orbital can be 6 only, and if all the 6 electrons are present in the orbital, it simply means that it is having a stable configuration. ये बात याद रखिएगा. Means any orbital used to attain either half field configuration or full field configurations to define the stability. ठीक है. अब देखिए, अगर मैं नाइट्रोजन की बात करूं तो इन केस ऑफ नाइट्रोजन द atomic number is 7. So the number of electron will be 7, and as a consequence, if I will try to write the electronic configuration, it will be 1s2, 2s2, and 2p3. Clear है? यही तो होगा. Okay. Now just think about oxygen. In case of oxygen, it will have atomic number 8. So I'm trying to write the electronic configuration for oxygen. So it will be 1s2, 2s2, 4 हो गए, and in P there will be the electron and the number of electron will be 4. Clear है? यही तो होगा. अभी forget about the ionization. Just we are trying to write the electronic configuration of given element. Nitrogen 1s2, 2s2, 2p3. Oxygen 1s2, 2s2, 2p4. अच्छा. अब the first checklist what we need to do is after the ionization what will be the configuration. अब देखिए क्या होगा. नाइट्रोजन का लिख रहा हूं मैं. एक इलेक्ट्रॉन हटा देंगे तो क्या होगा? 1s2, 2s2, एंड एक इलेक्ट्रॉन निकल गया तो क्या होगा? 2p2. बराबर है. Similarly, if you will try to remove one electron from the oxygen, what will be the configurations? The configuration will be 1s2, 2s2 and 2p3. यही होगा. अब चलिए एक नजर डालते हैं. See, in case of P, half field configuration will be 3 electron, as I told you, right? And half field is a stable. After the full field, the maximum stable configuration is half field. Yani, in short, I can say that nitrogen has attained a stable configuration. What about oxygen? P में कितने हैं? Total number of electron available is 4. It's a half field? No, it is more than half field. But whether it is full field? No, it is not full field. So basically, it is ranging from more than half field, but less than full field. So it doesn't come into the matter of stable configurations. For a stable configuration, p orbital should have either 3 electron or the 6 electron. But it is not having any of this quantity. Now, nitrogen is having p3, means it is stable. After the ionization, what would be the fate? It will have p2, means from stable to unstable. What about oxygen? It is p4, but by removing one electron, it will obtain p3 stable. यानी अगर मैं इसको रिप्रेजेंट करूं तो ये u मतलब हो गया अनस्टेबल. अब आप ले लीजिए, मैं u लिख रहा हूं. और इसके बाद क्या हो रहा है? ये स्टेबल हो रहा है ऑक्सीजन. बट ये पहले स्टेबल था और अब अनस्टेबल हो रहा है. As I told you, no one will try to be get unstabilized. And if it has to be, then of course there will be resistance, and resistance means energy. So energy will be more. So in that case, I can say that the nitrogen is having higher ionization energy with respect to oxygen. Answer क्या लिखेंगे? Since the nitrogen is having the electronic configuration 1s2, 2s2, 2p3. However, the oxygen is having the electronic configuration 1s2, 2s2, 2p4. By the process of ionization, the nitrogen has to lose the electron and will have to opt p2 configurations. Parallelly, the oxygen has to opt p3. So basically nitrogen will try to move from stable to unstable configuration, which is not feasible, and that's why in this process we need to put enormous energy to compensate the resistance. However, in case of oxygen, it will happily be ready to shed up the electrons to sustain the stability. That's why the nitrogen is having more ionization energy with respect to oxygen. Clear है? आगे बढ़ूं? देखिए ये एक यहाँ पर मैंने आपको केवल एक एग्जांपल दिया, ऐसे ही दूसरे पीरियड्स में भी हो सकता है. सो आई कैन आस्क एनीथिंग इन द एग्जाम, जस्ट यू नीड टू डेवलप द लॉजिक एंड ट्राई टू रिस्पॉन्ड इन द सेम वे. अभी तो क्या है, यहाँ पर मैंने ये लिख दिया, बट अभी मैं आपसे पूछना शुरू करूं कि भाई मैग्नीशियम और एल्युमिनियम की कंपेयर करूं तो now see magnesium is having 282 यानी 1s2 2s2 2p6 and 3s2 यानी s में फुलफिल्ड है, और एल्युमिनियम का क्या होगा, 3p1 होगा. तो of course aluminum will try to shed up the electrons to sustain the stability, and that's why aluminum will have a lesser ionization enthalpy with respect to the magnesium. यही तो होगा, यही तो हो सकता है ना. तो इसीलिए आप just what you need to focus, half filled and full filled, stable and unstable, that's it. You will be able to respond the questions which will be asked to your exam. Logic develop करिए यहाँ पे, ठीक है. I guess I have responded all the 5 questions which we have shared in the last lecture. Shall I move now? Or anyone is having any doubt, they can ask me. Anyone till now? Any doubts? We will move towards the next thing, and that is a factor which is responsible for ionization enthalpy. तो देखिए यहाँ पे पहली चीज आई है एटॉमिक साइज, ठीक है. देखिए अभी आपको पता है, मैंने अभी जस्ट नाउ वी हैव डिस्कस एटॉमिक साइज से क्या होता है. इफ एटॉमिक साइज विल बी मोर, then force of attraction will be lower, so the ionization enthalpy will be lower. ये अभी हमने बात की, वही इसको मैंने यहाँ पे एक स्टेटमेंट में कन्वर्ट किया. देखिए क्या लिखा है, आयनाइजेशन एंथैल्पी या पोटेंशियल इज हैविंग इनवर्सली रिलेशन विद रिस्पेक्ट टू एटॉमिक साइज. इसको याद भी आप ऐसे रखिएगा, कूलॉम्स लॉ क्या कहता है, F इज प्रोपोर्शनल टू 1/r², है ना. यानी इफ R is going to be increase, of course F is going to be decrease, और F कम हुआ तो आप समझ लीजिए आयनाइजेशन पोटेंशियल भी कम होगा, क्योंकि IP एंड F इज डायरेक्टली प्रोपोर्शनल. अब मैं चाहूं तो F को यहां से हटा सकता हूं और क्या लिख सकता हूं, IP इज हैविंग इनवर्सली रिलेशन टू एटॉमिक साइज. मैंने इस बारे में आपको समझाया भी था कि क्यों होता है ऐसा. So basically I have given one example that suppose I am dealing with 150 student in a classroom, regular classroom. Just imagine the last student who is sitting in the last bench. Will he or she feel the same hold of the teacher which second, third or first row of the students are facing for? No, it's not possible. And especially if the row, just penultimate row of that fellow is having 32 students. So for me it's a very difficult to approach that fellow, and it might be possible that suppose I have turned up to write anything on the blackboard, it has been that fellow has been bhagya out, ran away from the class. That may be a feasible, right? So means it's very easy to that fellow to leave the class. Similarly चलिए क्लास के रिस्पेक्ट में हम एटम के बारे में सीख लेते हैं. अब देखिए एटम, न्यूक्लियस सपोज मैं था, and student means electron. Now think about the last electron. The valence electron is the last electron, right? Now you think about the fate of the last electron. What would be happen? See, the holding capacity of the nucleus to the last electron will be of course diminished. Why? Because first of all the atomic size has been increased, so the force of attraction of the nucleus as well as the electron is going to be decreased. Parallelly, because of the presence of so many electrons in the cell, my force of attraction will not be reached to the last electron or the last student because of shielding effect, and that's why on increasing from the atomic size ionization potential used to decrease. तो यही हमने यहाँ पे लिखा है. ठीक है। सेकंड है इफेक्टिव न्यूक्लियर चार्ज। अच्छा, ये इट इज डायरेक्टली इफेक्टिव न्यूक्लियर चार्ज क्या होता है? देखिए सील्डिंग इफेक्ट के बारे में अभी हमने बोला ना कि सील्डिंग इफेक्ट बढ़ता है। देखिए क्या होता है, हम लिखते तो हैं कि लाइक अभी हमने लिखा 7 and 14, यानी होना ये चाहिए कि जो इलेक्ट्रॉन है, लास्ट इलेक्ट्रॉन, वो 7 प्रोटॉन के फोर्स ऑफ अट्रैक्शन को एट अ टाइम फेस करता है। बट याद रखिएगा ऐसा नहीं होता। क्यों? सी द लास्ट इलेक्ट्रॉन किसमें है? 1s2 2s2 2p3, यानी 2p3 से पहले क्या आ रहा है? 1s2। तो 1s2 जो फोर्स ऑफ अट्रैक्शन न्यूक्लियस से फेस करेगा, जस्ट एज अ कॉमन सेंस सोच के देखिए, 2s ऑर्बिटल भी सेम करेगा क्या? नहीं। क्यों? सी इट्स नेक्स्ट आफ्टर द न्यूक्लियस, द नेक्स्ट ऑर्बिटल इज 1s2, तो वो तो ज्यादा ही करेंगे ना। अब 2s2 उससे कम करेगा और 2p उससे भी कम करेगा। तो विद रिस्पेक्ट टू द इलेक्ट्रॉन इन द 2p ऑर्बिटल, इफ आई विल कैलकुलेट द इफेक्टिव एटॉमिक नंबर, इट विल ऑलवेज बी, इट ऑलवेज कम लेसर देन द असाइन्ड वैल्यू। मतलब जैसे मैं बोलूं 7 and 14, so don't be think that the 7 protons are having the same pattern या same force of attraction to the last electron. No, if you will calculate what it will become, it will become 6.93, थोड़ा सा कम हो जाता है। क्यों? वही सील्डिंग इफेक्ट, थोड़ी बहुत तो सील्डिंग इफेक्ट आएगा ना, स्क्रीनिंग इफेक्ट जो भी आप बोलते हैं, जो क्या करता है, चीजों को एक तरीके से कवर्ड कर लेता है। ठीक है। अभी देखिए, अभी मैंने एग्जांपल दिया था कि सपोज इन माय क्लास देयर विल बी अ 150 स्टूडेंट, जस्ट इमेजिन अ लास्ट स्टूडेंट, या a student who is sitting in the last bench, right? Whether I will have the same hold on that fellow? No, of course not. Of course not. It is not possible. But what about the students who are sitting in the first row? Of course, in that case, the force of attraction will be more because I'm present over there, right? So even though the teacher is present, even though the same teacher is present, but with respect to that teacher, if you will see the attention or the force of attraction, yeah, whatever you want to say, you can use it. It is going to be vary. Similarly, in case of any element, even though the same atom is present, but the force of attraction is going to be vary because of the presence of so many electrons in the various cell, and those electrons will try to sealed the last electron. जैसे आप लोग नहीं करते हैं, किसी दोस्त को बचाना होता है तो हम ऐसा 20-40 स्टूडेंट रख देंगे तो समझ में नहीं आएगा टीचर। तो सेम थिंग द एलिमेंट यूज्ड टू डू इट, एंड इन दैट केस द आयनाइजेशन पोटेंशियल इज प्रोपोर्शनल टू इफेक्टिव न्यूक्लियर चार्ज, और सील्डिंग के इनवर्सली होगा। अभी हमने बात किया। अभी हाँ, जस्ट नाउ वी आर टॉकिंग अबाउट द स्टेबिलिटी ऑफ फुलफिल्ड एंड हाफ फिल्ड। देखिए ये अभी हमने बात भी की थी, अभी नाइट्रोजन का एक और ऑक्सीजन का एग्जांपल सॉल्व किया था। In that I told that since the nitrogen has attained the half filled configurations, so in that case the stability is more for nitrogen with respect to oxygen. So any attempt to remove the electrons from the p3 orbital will need to have a more energy to required for instability, and that's why the ionization energy of nitrogen is more. Similar statement is being given here that first of all you remember half filled and full filled will be more. Up if suppose you will compare in between half filled and full filled, matlab P3 and P6, so remember P6 will have more stability, and more stability means more stable configuration, and more stable configuration means higher energy of ionization, yani ionization potential will be more in compared to half filled and full filled. Which one will be more? Fulfilled will be more with respect to half filled. मैंने रीजन अभी आपको शेयर किया। So these 4 factors are being responsible to divide the ionization potential. One is atomic side, second is effective nuclear charge, third is shielding effect, and fourth stable configurations. So remember, in case of atomic side, ionization potential is having an inversely relation with atomic side, means if the atomic side will be more, ionization potential will be less. I told you why, because F force of attraction क्या हो जाता है, कम हो जाता है। Second thing is that effective nuclear charge. So remember, effective nuclear charge and shielding effect are related, interrelated, क्योंकि बोलते भी हैं Z star is equal to Z minus sigma. सिग्मा क्या है? स्क्रीनिंग कांस्टेंट। Z क्या है? न्यूक्लियर चार्ज। जैसे तो इसके बारे में हम बात भी करेंगे, बट वी विल डिस्कस लिटिल लेटर। सो शील्डिंग इफेक्ट इज हैविंग इनवर्सली रिलेशन। व्हाट अबाउट स्टेबिलिटी ऑफ हाफ एंड फुल फील्ड? Full-filled configuration will always have a more stable nature with respect to the half-filled. So in other way around, I can say that the full-filled stable configurations used to have higher ionization energy with respect to the half-filled. But remember, if there will be a comparison between half-filled and other type of stable configuration, the stable means any other type of configuration, then half-filled will be more. So the order is full-filled is more than half-filled is more than any other type of configuration. Any other matlab, if you will compare P4 and P3, which one will be more stable? P3 will be more stable. If you will compare with P5 and P3, which one will be more stable? P3 will be more stable. But if you will compare P3 and P6, which one will be more stable? P6 will be more stable. Okay? Chalo. So